So our app seems to slow down when we switch between calendar days. This is where the CPU profiler comes in, which can show us which parts of our JavaScript are slowing the page down. Let's create a profile by clicking on the Profiles panel, selecting Collect JavaScript CPU Profile, and click the Start button at the bottom. Now we're recording, so we'll switch to the next calendar date. When it's finished, we'll hit the Stop button here. What we're then presented with is a bunch of different functions that were called and how much CPU time they each took. Up at the top of this list, we see a function called window calendar get events for date, and this took up 13% of the time. We can dive into this function's code by easily clicking on the file name and line number on the right. It appears we're looping through every single millisecond of the day to see if our event is happening on that particular millisecond. This is a pretty expensive operation, and it's probably overkill. So let's refactor this code to take a look at the first millisecond of every day instead of every millisecond of every day. Alright, now that we've fixed the code, let's redo our profile by going back to the Profile panel, select Collect JavaScript CPU Profile, and click Start. Then we switch dates, stop when the operation is complete, and click on the new profile in the profile list to view the results. I think previously Get Events for Date was right at the top of the list, and we can click back and forth between the two profiles to compare them. Now it's not even on the top 10. Looks like we fixed it. Let's go back into the CPU profiler and see if we can make any more optimizations. We'll start another recording and start switching days again. There are no second-long stalls this time, but it seems like the animation intended for adding a new event is being run for every event on the page, and, well, it's just not very smooth. On our timeline here, we can find a few instances where the JavaScript and the rendering are much longer than 30 frames per second. We use our display event function to add our events to the page. Here you can see we added a conditional to determine if we should add an animation effect when we display out the events. In our createEvent function, we called the display event with the animated parameter set to true. We also call it in the display date for each event we add to the page. Here you can see the animation is set to true, but it really should be set to false, so it doesn't call that animation every time it renders an event on the page. It was likely this event that was slowing the page down. Let's correct this and switch it to false, so we don't animate old dates. Now let's switch back to the frames view and make another recording. We'll try switching dates again, a couple times for good measure. Once we stop the recording, you can see on our timeline that scripting, rendering, and painting for each frame is now completing faster than 60 frames per second most of the time. The frames view can quickly alert you to performance problems, and then the CPU profiler can help you track down where your slow JavaScript code is happening. And it's time for you to get your hands dirty in the challenges.